Welcome. Under quantum numbers, how to find the four quantum numbers of an electron. How to find the four quantum numbers of an electron. In our introduction video, I already made it clear that we have the four quantum numbers. We talked about it in our channel. Endeavor to watch it. The L, the N, the L, the ML, and the what? The MX. Now they will give you a question and ask you, get or calculate this or get these four quantum numbers from a particular question. Let's go straight to the point, please. Now you have, for example, you have 3p2, and then they ask you, find the four quantum numbers using the question above. That's number one. You have 3p2. Now, how for you to determine the energy level? Is this number at the back of P? It's always the number at the back of either S, P, D, or F. So automatically your N is equals to what? 3. Now, how can you determine your L? Now, your L, from the first video I made on quantum numbers, I told you that this determines the shape. And then the L value always range from 0, 1, 2, 3. And whenever L is 0, that is S. Whenever L is 1, that is P. Whenever the value of L is 2, that is D. And this is what? F. And so if there is P here, that means that the number for L must be what? 1. So that means your L here is equals to 1. Now remember I said that ML starts from what? Plus L to minus what? L. That's the range. So automatically, if you have L, you already have ML. And so the value for your ML is minus. You start from minus to plus. So minus. So the value should be minus 1, 0, 1. So that's what? The value for your ML. Now, how can we determine MX? I want you to picture this visually. If you understand it, this is so easy. Now, we already have the energy level to be 3. And we use this P to determine that the number of L is 1. How can we determine MS? For you to determine MS, you need to draw it. Picture it visually. What am I saying? Look at. How many subshells are in P? We have 3 subshells, right? We have 3 subshells. And then the number of electrons in P is just 2. Using the principle of Hund's rule, at the part 1 of the video I said electron will enter singly before what? Pairing. And so if the maximum number of electrons in P orbital here is 2, that means you have to put it first like this. You put it, electron must enter singly before what? Pairing. And remember that the value for MS, like I've already said it, if the arrow is upward, the answer is plus 1/2. And if it's downward, the answer is what? If it is upward, the answer is plus 1/2. If it is downward, the answer is minus 1/2. And so we already got the answer for N. We already have the answer for L. I've already calculated the ML. The next thing is to get the MS. And so we can see that the number of electrons, the maximum number of electrons here is 2. And I just put it into the subshell. So the arrow here, you can see even from ML, this is minus 1, 0, and 1. Now, the arrow here is what? Upwards. That means that your answer to MS is plus 1/2. So the answer to the above question is your N is equals to 3, your L is equals to 1, your ML is minus 1, 0, 1, while your MS is what? Plus 1/2. That's the answer. It's so easy. Let's solve another example so that you guys will understand it perfectly. Now, they ask you to calculate or using the above question, get the 4 quantum numbers. Let's say we have 4D9. This is example number 2. Now automatically you already know the way I like answering this question, immediately I see this, the first thing I normally used to do is I'll just write SPDF. That's what I normally used to do on my own. So find the method that works for you. Then the next thing I will do is I already know that this is 1, 0, 1, 2, 3. And so from here, my M automatically is 4. The number, the coefficient of the alphabet is always the energy level. And so from here, D, I'll now come. So D, for this thing to be D, that means your L value must be what? 2. The next thing is, immediately you get your L, ML is already in place. So this is equals to -2, -1, 0, 1, 2. That's it. The next thing is for you to calculate your MX. Your MS, right? And so we have to draw it for you to understand it. Then the first thing you have to do is, how many orbitals, how many shell does D have? Into D orbitals, we have how many subshells are in D orbitals? So we have 5, right? 1, 2, 3, 4, 5. And so we have the maximum number of electrons here is 9. Remember Hall's rule. Electron has to enter singly before pairing. So the first thing is it will enter singly like this. Remember the arrow up. Enter singly like this. Enter singly like this. So you already have 5 electrons. 1, 2, 3, 4, 5. The next thing is it will now start pairing. Then you put it like this. The arrow is now downward. The arrow is now downward. The arrow is now downward. And so listen very well. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. We have only 9 electrons, right? Now, remember this ML. In our introduction video, I've said a lot of things about that ML. I told you that it specifies the orbital within the subshell. So once you already have your ML, you can also see, even from here, you don't even need to ask yourself how many subshell does D orbital have. From your ML here, you now know it's 1, 2, 3, 4, 5. Let me even be writing. Here is -2, here is -1. Yes, -2, -1. Here is 0, here is 1, and here is 2. Now, the next thing is the MS. Look at the last electron in this shell. And you can see that it is what? Downward. That means your M, the value of your M is what? -1/2. And that's the answer. It's so easy. It's so easy, guys. I'm taking my time to explain this video so that, you know, there will not be much confusion. I hope you guys are following me. So let me go to another example. Example number 3. Get the 4 quantum numbers. You have 5F7. Do you know what to do? Of course. The first thing, like I said, I like doing it SPDF. So here is 0, 1, 2, and 3. If this is the coefficient 5, that means your M is what? 5. The next thing you want to get your L. And for L to be F, it has to be what? Number 3, right? And so your L is number 3. And so your ML range from -L to +L. So -3, -2, -1, 0, 1, 2, 3. And so you can see we have how many subshells? We have 1, 2, 3, 4, 5, 6, 7. And of course, the F have what? 7 subshells. And so you want to draw it for you to calculate your MS. This is 1, 2, 3, 4, 5, 6, 7, right? And so remember, using the principle of Hall's rule, electron have to enter singly before what? Pairing. So this is, let's enter here, arrow upwards. And so this is just the total of what? 7. You can see that the arrow is upward, and therefore your MS is equals to what? Plus what? Half. Remember, when the arrow is upward, the MS is plus half. Whenever the arrow is downward, the MS is what? -1/2. -1/2. And so that is it. Like I said, it's so easy. I have a question here for you, and that is classwork. What if you have number 4, you have 6 D5. What is your N is what? Your L is what? MS and ML. What's the value for it? Please solve it and drop your answer at the comment section for me. Thank you very much. That is a class work.